Hey everyone, welcome back to my channel Web Coding with Ankur. If you are new here, don't forget to hit the subscribe button and ring the notification bell so you'll never miss an update. Today we are diving into a classic problem in computer science, the Fibonacci series. We are focusing on solving it using the recursion in JavaScript. So let's get started. So now for the solving the recursive Fibonacci series, first of all we have a problem statement. In this you can see we have a given number for the first nth element of Fibonacci sequence. Then, what is the Fibonacci sequence? The Fibonacci sequence is a series number in which each number is the sum of preceding two numbers. As you here see the example, the sequence is 0, 1, 1, 2, 3, 5, 8. Here, in this case, we are using the recursive function to calculate the Fibonacci number. So, now what could be the function so far? Here, you can see a recursive function for 0 would be output is 0. Recursive function 1 equal to 1 and recursive Fibonacci series 6 function value will be output will be 8. Now let's talk about the tips to solve the recursive problem. Here we can first of all we have to understand the problem of solving the problem using the recursive solution. First, identify the base case. The base case is the condition under which the recursion will stop, making sure it is well defined to prevent infinite recursion. Then we have to define the recursive case, determining how the problem can be broken down into smaller sub-problems that resemble the original problem. After that, we can visualize the example. We walk through the problem with a simple example to understand how the recursion will unfold. So, if you necessary, you can draw the diagram also. Now, to we keep the recursive function as clearly and concise as possible in order to avoid unnecessary complexity. Means you have to keep it the simple recursive, keep it simple. Now let's identify the base case in our problem. A base case is every recursive solution need a base case, a condition to terminate the recursion. Let's understand in terms of Fibonacci sequence. In Fibonacci sequence, the number is the sum of the two preceding numbers. For example, sequence number 0, 1, 1, 2. In this, 0 and 1 is the our base case. That is f1 equal to 1 and f of 0 is equal to 0. So, how we consider that this is 0 and 1 are base case. So, let's verify it. As here you see an simple equation of f to the fn equal to fn minus 1 plus fn minus 2. Let's take n equal to 2. Then what our equation would be it as given below. If we keep n equal to 2, then what we get? f2 is equal to 2 f2 minus 1 plus f2 minus 2. Because we keep it n equal to 2. So after summarizing this equation, we get f2 is equal to f1 plus f of 0. So let now make what value comes here with f of 1 and f of 0 would be f of 1 is 1 and f of 0 is equal to 2. So what would be f2 will be here we get 1 plus 0 is equal to 1. So here f2 is equal to f2 or 2 is equal to 1. So this is how we can identify the base case in our problem. Now let's move on to our replit to solve the recursive to solve the Fibonacci series using recursive solution. So let's get back to our replit platform. Here you can see my replit, and so we can start calculating the recursive solution for the Fibonacci series. So first of all, we can make a function of recursive Fibonacci, keep it at 0. Then recursive Q of 1. Then recursive not Q of 6. Okay. Now we can also control that we can got the output. What could be the output of this? Here I'm taking the three values 0, 1, and 6 to calculate the recursive, and I in the comment I also written what the output should be of the program. So you can get the output of this program as given here. So let's start building this function. So first of all, we can build the recursive function. Recursive function recursive Fibonacci of n. Here, as you can see that in the recursive solution, here you can see that in the recursive solution we have if n of 0 or 1, because we have in recursion we have 0 and 1 as the base case. So what if the value is smaller than 2, then we have to return n, because maybe the if value of 0 it will return 0, and if value of 1 it will return 1. So we have to write if, we have to make a condition here, if n is smaller than 2, then we have to write return n. Else what we have to do, we have to make value divide, like if n is equal to 2, if you have n is equal to 2, then we have to make n minus 1 is equal to 2 minus 1, which is 1, and n minus 2 is equal to 2 minus 2 is equal to 0. So for which if n is equal to 2, then which value we have to do, we have to keep it 1 and we have to plus 1 plus 0, so that we can get value 2 of 1 if value of 2. So what we have to do in this, so we have to insert this case, we have to return recursive Fibonacci n minus 1 plus recursive Fibonacci n minus 2. Now we have to remove this particular thing. Now let's run this particular program and see what the value of this integer which we passed in this function will return. So our base case is already here of n 0 and 1. I have already tell you, and let's see that we get the required output which we expected. For 0 we expect 0, for 1 1, and 6 for it. Let's run the program. Here you can see we get the same output as we expected. This is how you can calculate the recursive calculate the Fibonacci series using the recursive solution. Now we calculate the big O notation for this. What is the big O notation for this? Big O notation for this is big O 2 of n. Why? Because in the base, if O of n is an iterative case, if you go to your cheat sheet, you see that in the 0 of n is of iterate for the iterative approach. While in this it is the recursive approach. Why we get O2 to the power n? If you let move to our here, you can change the relative time complexity. If the n value is 4, then we have to, it had two values, it had 3 and 1, n minus 1 and n minus 2. After that we get 3 out of this, we have 2 and 1, 2 n minus 1, which is 3 value of n is 3 and n is 3 minus 1, 3 minus 2 1. Okay, like this. So if you go to a level chart, you can see that n is equal to 1 and n is equal to 2 and n is equal to 3. Here on each level the value is incremented in the double child. First level is 1, second level is 2, third level is 4. 2 to the power 4, 2 to the power 2 and 2 to the power 1. So it can increment it or it will double on each level. Okay, 1, 2, 4, 8, 16, it will be double like this. So for recursive approach, as you can see here that in this because it is a recursive solution, we are finding this is a recursive approach O of 2 to the power n. This is how we can calculate the big O notation for this. One more thing I have to tell you, that big O 2 to the power n recursive approach has bad, horrible operations. Let check out. I want to show you the graph. Here you can see that O 2 to the power n is horrible, because here you can see a horrible tab. Here O to the power n, it is not for current Fibonacci sequence for calculating the recursive solution. For calculating the Fibonacci sequence using the recursive solution, it is for the bad operation, as it is horrible as compared to O of n, which is an iterative approach. So it is not a good approach to calculate the Fibonacci series using the recursive solution. As we are reached out to our conclusion of this video, so as you can see that how we can calculate the Fibonacci series using the recursive solution. So while the recursive solution is simple and elegant, it is not the more efficient for large value of n due to the exponential time complexity. Each call to the function generated 2 more calls, leading to a lot of redundant calculation. In future video, we will look at more efficient way to solve the Fibonacci problem, like using dynamic programming. And that is for today's video. I hope you found this explanation of the recursive solution for Fibonacci series helpful. If you did, please give me this video a thumbs up, share it with your friends, and leave a comment down below if you have any question or topic you would like me to cover next. Thanks for watching, and I will see you in the next one.